Hey, my students, how's Algebra 1 going? If you are here watching and listening to this video, then you are doing a great job of doing your very best in my class. I appreciate your hard work. And you're taking the opportunity to review and maybe learn something a little bit new as we take a look at these few questions on linear equations. All right, so our focus for this unit has been to work with these three forms of our linear equation. So slope-intercept form, we know that one. And we also have been working a lot on point-slope form, which remember looks like this. That's if we have a point and a slope. So point-slope form. And let's see if I can squeeze standard form into the corner here. Ax plus by equals c is called standard form. All right, just enough room there. So at any point in time, if you need to remember these formulas, you should maybe write them down someplace as you're studying or trying different problems. It's always helpful to have your formulas close by. Okay, so a reminder where numbers are going to kind of fly into these formulas. For the slope-intercept, you're going to have the slope and the y-intercept in place of your m and your b. For point-slope, you're going to have your point represented here with x sub 1 and y sub 1, and your slope is represented here in this box with an m. And then in standard form, remember we talked about how a lot of times standard form is used when you're talking about kind of totaling two different things in some way. For example, the price of apples and the price of lemons, costing a total bill, and then working to figure out what that would mean if you bought one lemon versus one apple, or two apples and three lemons, how would that work out? So kind of if you're kind of comparing two things, right? And then you're comparing it to a total amount or value. Sometimes we can use standard equation for things like that. Okay, so with that said, let's go ahead and graph this line. All right, so here it is way up here in the corner. It's a little bit hard to see, so I'm just going to write it again. Y plus 2 is equal to 1/2 times x minus 4. Now, one of the things I want you guys to be able to do with an equation given in point-slope form is to identify the point. What is the point we're talking about here? And also identify the slope. Okay, so we want to practice that. I can see that the slope is going to be 1/2. I can find it right here. There it is. And you want to be a little bit careful on identifying your point, because you want to grab your x sub 1 from this place, and remember it's the standard formula is minus a y sub 1, so this would actually be minus a negative 2 for your y sub 1. So the point is actually 4 comma negative 2. Now, finding the point and the slope and graphing the point and the slope is one way to graph your line, right? 1, 2, 3, 4, and negative 2. A slope of 1/2 means a rise of 1 and a run of 2. So we have this 1/2 slope that is going across our coordinate plane. Now, is there another way to do this problem? Well, you could go ahead and take the y plus 2 equals 1/2 times x minus 4, distribute your 1/2. We've been practicing this a little bit. So we get y plus 2 is equal to 1/2 x, and then 1/2 times 4 is going to be minus 2. If we subtract 2 from both sides, and I was going a little fast there, so if you need to slow it down, go ahead and do that. And we get 1/2 x minus 4. Well, let's see if that minus 4 y-intercept works out. Here's my y-axis, here's my x-axis. 1, 2, 3, negative 4. There it is. And it all worked out very nicely. So good job on that one. All right, another thing that we learned quite a lot of in this unit, or worked with quite a lot, was with finding slope. So I'm going to go ahead and push those things up from my screen, and I'm just going to remind you guys of the slope formula, that you can find the change in your y values and divide that by the change in your x values, and that will allow you to find the slope. Okay, so as you look at a table, one of the things you can do is you can just pick 2 points in your table. So I'm going to pick this point, and I'm going to pick this one right next to it. So this is the point 0, 35, and the point negative 1, 26. And I'm going to go ahead and put my y values, right? I'm going to subtract those in the numerator. So I know my slope for this table, it looks like it's going up by 9 and then up by 9 again, then up by 9. So I'm probably looking at a numerator of 9, and then the denominator, let's see what's happening with it. It's going up by 1, up by 1, up by 1. So since I did 35 minus 26, I want to do 0 minus a negative 1, which is going to be a positive 1. So my slope of this line is 9. Now, I can either use a point and write the equation in point slope form, but check this out right here. This spot where I have x is 0 and y is 35. I don't even think I can plot that point on my graph because I don't have 35 boxes. I could renumber these, of course, so I could make them go up by 5s or 10s or anything, 2s to get there. That would work as well. But I think rather than having to graph this one this time, let's just go ahead and use our y-intercept, which we know is 35, and our slope of 9, and let's just write our equation. Y is equal to 9x plus 35. So again, we know that the y-intercept is given because of this point. X is 0, y is 35. That is the actual point that is your y-intercept. Okay, and don't forget, this is the formula we used this time. We use slope-intercept because we had the slope, we have the y-intercept, and so we plug things in for the slope, for the m and the b, and this is what we got right here, 9x plus 35. All right, let's try a couple more. I think we have enough time. We'll cruise this through this next one a little faster. Again, we're working with slope. Here it is. Check it out. We have 2 points this time. 2, 8. Okay. And the point 5, negative 1. Gosh, let's just plot them and see if we can't figure out what the equation is just from our graph. Let's try it. 2, 1, 2, 3, 4, 5, 6, 7, 8. 2, 8. And 5, 1, 2, 3, 4, 5, negative 1. All right, so this is going to kind of shoot up and off of our, oh, there it goes. It's going right off our grid. It's going to be hard to tell what the y-intercept is up here, but that's okay. We know the slope. You can find the slope by taking negative 1 minus 8. And then 5 minus 2, so you could find your slope this way. negative 9 divided by 3, which is equal to negative 3. Or you could find your slope this way. You could go, I go down 1, 2, 3 over 1, down 1, 2, 3 over 1, down 1, 2, 3 over 1. So it looks like my slope is a negative 3. So you can kind of stair step it down your line to determine your slope as well. Okay, well that's all we need, guys. All we need is a point and our slope, and we're going to throw this into the point slope form. So it's going to be y minus 8 is equal to, what number is going to go here? Maybe you want to pause the video and try and write it on your own and then check back in. This is going to be where our slope goes. X minus 2. And don't forget your algebra. This is a fine answer, but if you want to show off a little bit and you want to do some crazy algebra and practice, use your distributive property and convert this point slope form of the equation into, add 8, the slope intercept form of the equation. So we get y is equal to negative 3x plus 14. That seems about right? That plus 14, that's probably about plus 14 way up here somewhere, right? I bet that is. Okay. One more, then we'll be done. I think, oh my gosh, I have 2 more. Here, let's zoom up to this one. Let's try this one in standard form. I think the best way to tackle a problem in standard form when you're working with graphing, you could convert it to the form y equals mx plus b. A lot of people like to do that, like solving a literal equation and rearranging your terms and solving for y, and that's totally fine. I kind of like the strategy of making a table and plugging in a 0 for x and a 0 for y and plotting those 2 points. Okay, so let's try that strategy. Okay, let's use purple for plugging in a 0 for x. So 5 times 0 minus 7y is equal to 35, which means 0 minus 7y is equal to 35. And if we divide both sides by a negative 7, don't forget your positive divided by your negative is going to be a negative 5. Perfect. So that's going to be one of our coordinate points. 0, 1, 2, 3, 4, negative 5. That's going to be one of our points. Now we're going to flip over to this other side, and this time we're going to plug a 0 in for y. So let's try that. 5x minus 7 times 0 is equal to 35. So that means 5x minus 0 equals 35. So essentially we have this equation. When we're simplifying, we can divide. And we get x is equal to 7. Okay, that goes here. So I've already plotted the point 0, negative 5. I also want to plot the point 7, 0. So 1, 2, 3, 4, 5, 6, 7... 7, 0, and then I just draw the line between those 2 points. And that's all the time we have for today, guys. I hope those examples have been helpful to you. What you would find, I am sure, is that this 5/7 slope would occur if you were to actually convert your standard form into slope-intercept form to graph, if you'd rather do it that way. All right, you guys are doing great. Keep up the good work.